In this video, we're going to demystify public key infrastructure, PKI. PKI is the backbone of secure, trusted communications on the internet and within private networks. So why do we need PKI? If you recall, with asymmetric encryption, we utilize two keys, a public key to share and a private key to keep secret. When your public key is used so others can encrypt messages to you, only your private key can decrypt them. If you missed that, go back and rewind. It's a very important concept. You don't want to miss it or you'll be lost for the rest of the video and other videos. So anyways, you sign a message hash with your private key so recipients can verify authenticity with your public key. But how do you know that public key really belongs to the person or server it claims to belong to? In case that breakdown was not clear, here's a real-world example. I want you to imagine you're online communicating with your bank. The connection is reported as secured because the data you are sending is encrypted by your website public key. But how do you know you're really talking to your bank and not a fake bank using their own public key? PKI solves this by wrapping public key into digital certificates. A certificate is like a driver's license for a public key. The certificate simply declares this public key belongs to www.bank.com. It's digitally signed by a certificate authority, CA. The CA is a reputable PKI company like VeriSign and Entrust. People trust them the way we trust the state to sign and issue our driver's license. A private CA lives inside an organization. The certificate they issue are only trusted by internal systems and users. A third-party CA, like, I just mentioned VeriSign and Trust, they are internationally known. They issue certificates that nearly every browser and device will accept. Continuing our conversation on CA. Their functions include registration, meaning they verify applicants' identity before issuing a certificate. They also conduct issuance. This is where they sign and publish certificates so clients, aka users of the certificate, can fetch them. They conduct trust management. They maintain trust relationships with users, governments, and enterprises. They have lifecycle management. They are responsible for revoking compromised or expired certificate and publishing revocation data. And lastly, they are responsible for repository services. This is where they host certificate repositories and make them available for clients. So how does PKI work? Well, let's start from the top. First, you have to request a certificate from your CA. The CA verifies who you are to make sure that you truly are the organization you are declaring to be. The CA then signs your public key and issues a certificate. Now the clients or the people that are going to use your public key, they go in and fetch and cache that certificate, trusting it because the CA is on their trust list. When you sign or encrypt with that certificate, recipients of your certificate public key are confident that it's genuine. Here's a recap. PKI turns raw public keys into trusted credentials. Digital certificates backed by CAs solve the identity problem. Choosing the right cryptographic solution, private versus third-party CA, depends on your company use case. See you in the next one.